Most of the time in geometry, we're going to be working on the coordinate plane. So it's important that you understand how to find the weighted average formula on the coordinate plane. What we're doing is we are applying the weighted average formula twice, once for the x coordinates and once for the y coordinates. If A has coordinates x1, y1, B has coordinates x2, y2, and A and B weigh W1 and W2 respectively, then point P, that represents the weighted average of points A and B, is located at the coordinates P, W1 x1 plus W2 x2 divided by W1 plus W2, comma, W1 y1 plus W2 y2 divided by W1 plus W2, where W is greater than or equal to 1. Similarly, if points A, B, and C have coordinates x1, y1, x2, y2, and x3, y3, and weigh weight 1, weight 2, and weight 3 respectively, then point P has coordinates weight 1 times x1 plus weight 2 times x2 plus weight 3 times x3, all of that divided by weight 1 plus weight 2 plus weight 3, comma, weight 1 times y1 plus weight 2 times y2 plus weight 3 times y3, all of that divided by weight 1 plus weight 2 plus weight 3, where W has to be greater than or equal to 1. Find the coordinates of P that represent the weighted average of each set of points based on the given conditions. Point D weighs twice as much as E. Point E weighs twice as much as point F, and point D weighs 3 times as much as point F. Point D weighs twice as much as point E. So twice, remember, means 2, and point E has a weight of 1, so W1 is 2 and W2 is 1. Point D from our coordinate plane has coordinates -4, 2, and point E has coordinates 2, -2. So x1, y1 come from point D, and x2, y2 come from point E. When we substitute all of those values into our weighted average formula, we find that point P is located at -2, 2/3. Point E weighs twice as much as point F, so that means point E is 2, point F is 1, and point D weighs 3 times as much as point F, so D has a weight of 3. So W1 is 3, W2 is 2, and W3 is 1, because we're representing D, which was -4, 2. E is the next point on our line segment on our graph, which was at 2, -2, and point F is at 5, -4. So we're going to substitute all of those values into our weighted average formula and find out that P is located at -1/2, -1/3. Check. Students, please go ahead and complete the check now. Teachers, please pause the video. Check. For part A, point P is located at -8/5, 3/5, or if you put them as a decimal, -1.6, 0.6. B is 13/8, 11/4, or if you put them as decimals, 1.625 and 2.75. Did you get them correct? If not, go back and double check your work and see if you can identify the mistake you made. A school district is planning the location of a new bus stop on Main Street based on the number of children in each household who ride the bus. The district wants to use the location that represents the weighted average of the riders as the location for the new stop. The Molinas live at 6 Main Street and the Warners live at 64 Main Street. So the first thing that we're going to do is we're going to put the values of their homes on this number line. So 6 and 64. Now we need to figure out the weighted average. Part A. The Molinas have 2 bus riders and the Warners have 5 bus riders. Where should the bus stop be located? So the number of bus riders is the weight. So this is W1 and 5 is W2. Part B. Next year the Warners will only have 3 bus riders. Where should the bus stop be relocated? So for part B, W1 is still going to be 2 because the Molina's number of bus riders has not changed, but W2 is now going to be 3. Part C, describe the change in location of the bus stop. Does this make sense? Explain. So to figure out part A, we know that the weight of the Molinas is 2 and their location is 6. The Warners have a weight of 5 and their location is 64. So we're going to substitute that into the weighted averages formula. 2 times 6 is 12. 5 times 64 is 320. 12 plus 320 is 332. And 2 plus 5, which is in the denominator, is 7. 332 divided by 7 is approximately 47.4, which means that since the addresses appear to be whole numbers, that the bus stop is going to be between the address 47 and 48 Main Street. So for part B, the weights have changed, but the locations have not. So again, we're going to substitute that into the weighted average formula. 2 times 6 is 12, plus 3 times 64 is 192. 12 plus 192 is 204, and then 2 plus 3 in the denominator is 5. 204 divided by 5 is 40.8, so the bus stop should be between 40 and 41 Main Street. Describe the change in location of the bus stop. Does this make sense? Explain. Next year, the weight of the Warners will lessen, so the location of the weighted average should move closer to the Molinas. The midpoint is at 35, so it makes sense that with different weights, the location of P is at 40.8. Remember that a midpoint has a ratio of 1 to 1, and in part B, the ratio of the Molinas to the Warners was 2 to 3, which is close to a 1-to-1 relationship. Did you struggle with anything in this lesson? If so, how did you deal with it? Teachers, please pause the video and allow students to reflect on this question. Students, here is an exit ticket. Please complete it and turn it in before you leave. Teachers, please pause the video.